Okay, so in this video, we're going to go over the 3 simple steps to solve a limit. So there are 3 easy, simple steps that you can take with all limits in order to evaluate them. So yeah, we're going to go through that today and apply it to a couple of examples. So the first step here is to plug in what you're approaching into the limit or into the expression. And you really want to focus on what you get when you put it in there. So if it equals a number, sweet, you're done. That's all you have to do. So if it doesn't equal a number, if it equals like 0 divided by 0, infinity, anything strange, odd, then you want to go down to step 2. So step 2 is just to simply simplify. So find any way to simplify that expression and then plug in your number again, what you're approaching again. If it equals a number, you're done. You're good. So if it equals, you still simplify it or you can't simplify it. So if it equals 0 over 0, a number over 0, a negative number over 0, then it depends. It depends on what your teacher wants you to do in this situation. If you're not up to Calculus 2, then you probably just want to say, hey, that the limit does not exist. If you are in Calculus 2 and you can't simplify it, then your teacher is definitely going to make you, or might want to make you, use L'Hopital's principle on that limit. And actually, I don't know how to spell it. I just kind of freeballed that, so my bad there. But you get what I'm saying. So if you're in Calc 2, going into higher levels of math, you can use L'Hopital's principle on that limit. If you're not, simply Calc 1, then your limit just simply does not exist. All right, so let's use these steps and just solve some problems here. So the first problem, we have the limit as x approaches 1 of the square root of x plus 15. So we go through our steps. So this first step is to plug into the number, or plug it into your expression. Plug the number into your expression. So we plug that in there. We get 1 plus 15, the square root of that. We get the square root of 16, which is 4. And that equals a number, so that's our answer. We're done. Going on to example 2. We have the limit of x approaches negative 4 of x squared plus 6x plus 8 all over x plus 4. All right, that first step, let's plug it in. Let's plug in our number. So we're plugging in negative 4. And right off the bat, we can see that bottom is a 0. So it's not looking too good, because even if we get a number on the top, it's still going to be equal to infinity. So, but we're going to do the top just for completion's sake. So we have 16 minus 24 plus 8. That's equal to 24 minus 24 over 0, which is equal to 0 over 0. So we move into step 2, which is to simplify it. So we look to see, hey, we go back to the beginning, say, hey, can we simplify this? Well, yeah, you can factor the top, right? So when we factor that top, we get x plus 4, x plus 2, all over x plus 4. We look, and the top and the bottom kind of share a polynomial there, so we can x those out, cancel those out. So then we're left with the limit as x approaches negative 4 of x plus 2. Now let's start all over. Let's plug that number in after we simplified it. And we get negative 4 plus 2, which is equal to negative 2. And that's a number, so that is our answer. And going back to that, if we didn't get negative 2 out of that, if we got a weird still 0 of 0, a number over 0, negative number over 0, again, that would be, we already simplified it. There's no more simplification we can do, so that limit either does not exist or it's a limit we're going to have to use L'Hopital's principle on. All right, you guys, let me know what you think in the comments, and shoot me any questions, anything, any other problems you want me to go over. But I'll see you next time. Bye.